Alright, so in this one it says points D, E, and F are connected to form a triangle along the surface of a sphere. Points A, B, and C are connected to form a triangle on a Euclidean plane. So we actually have only talked very little about the difference between a Euclidean plane and a sphere, but this is the one thing we did talk about for sure, was the triangles in those space. So it wants to know which of the following statements is true. So let's start with the one that we've been using the most. And if you're looking down at the answer choices, it's all about angles. What do we know about these three angles on this triangle? Yeah, here they are all the same. They've marked it that way, right? But what else do we know, even if they hadn't marked them as the same? Say again? Yeah, but what if they hadn't told us that? What would we still know about all these angles? Okay. What do we know about them when we're adding them, like these answer choices are doing?
They're equal to 180.
Yeah, these are equal to 180. This is true every time you're ever on a flat triangle, right? But what did we say was true when you're on a sphere? It's always more than 180. Okay? So when you look at the statements, A, B, and C are equal to 180, and D, E, and F are more than 180, so then it becomes which of these is true. Right? I'm going to just start at the bottom because it's smaller. This one says that these angles are equal to 180. Can they be greater than 180 and also be equal to 180? No. This one, G, says that these angles added up are equal to these angles added up. Okay, so it comes down to, if you know your symbols, basically, you know that this one has to be more than this one. Which one of these is written to where these are more than these? F. Yeah, your sign right here. This one, they've given your sign backwards. They've said that these angles are smaller than these angles. So it is F. Again, always just read carefully because the way it gets changed up in wording, you don't want to just assume it's going to be the same every time you see a picture that looks like this. Alright, so here we have a triangle, and it says QR is a mid-segment of triangle DEF. So before we even read the question, what was a mid-segment? We talked about it when we were doing our constructions. We talked about how to create a mid-segment and what it was, and we had a triangle mid-segment theorem. So, I mean, if you break down the word, it's obviously a segment in the middle, but so were all those other ones, right? What specifically makes a segment a mid-segment? What's it connecting? It connects two sides. Where is it connecting them? In the middle, in the midpoint. So if Q is a midpoint and R is a midpoint, what does that tell us about QF and QD? They're equal. What's it tell us about FR and ER? They're equal. Okay? So, like I said, you have to be able to break those things down. It doesn't tell you that in the problem. Something we've learned previously does because we know what a mid-segment is. Alright, so it says if FD is 82 inches, so that's from here to here, RE, it says is 36 inches, RE is from here to here. Which statement is not true? Alright, so it says the perimeter of triangle QRF, which is the little one, is half the perimeter of DEF, the big one. It says the perimeter of the DEF, the big one, is 194. C says the perimeter of trapezoid DERQ is 117. That's this. And then the last one, it says triangle QRF, which is the small one, is similar to DEF. All right. So looking at this picture, both the little triangle and the big triangle share angle F, right? And if this triangle has a side that's half of this triangle and this side is half of this triangle side, are they going to be proportional? Yeah, they're half, right? So that actually lets you fill in some other stuff. But this is 36. It was the midpoint. So doesn't that mean this is 36 too? Yeah. So how much is it all the way from F to E? 72. All right. The same logic can be applied over here. This is 82. If it's broken into 2 equal halves, what is it from here to here? 41. And that means from here to here is also 41. And we just said that the baby triangle is half the length of the big triangle, right? So if this piece is 20, what's this piece? 40. And actually, you might have forgotten it, but I mentioned that triangle midsegment theorem. Remember, the side or the midsegment was parallel to and half the side that it wasn't touching. So we kind of already knew that. That's going to let us do the perimeters. Okay, so we already know that the little baby one is similar to the big one. So this is true, so it's out because it said not true, right? So somebody add up the sides of this trapezoid, the 41, the 20, the 36, and the 40. Tell me what the perimeter of the trapezoid is, because we need to know if it's 117. It's 138. So this is a no because it's 138. So that seems like the answer, but we always check them all. How about the big triangle, the perimeter? The 82, the 72, and the 40. Is it 194 together? (72 plus 82). It is 194. Okay. And then nowhere in the answer choices does it ask us for the perimeter of the little one, but it does say it's half of the big one. So add 41, 36, and 20. Is that half of 194? (41, 36, and 20).
Oh, it's 97. Sorry.
Is 97 half of 194? Yes. So the two that we said yes to are out. So the trapezoid was the one that was wrong. On this one, again, read them next time. Even if you see the same picture, the numbers probably aren't going to be the same. The wording might be different. The answer choices might look different. So make sure you're reading it every time. Anybody still tapping on slide 7? No? Okay. Okay, slide 8 says in triangle WXY, WZ is a median. Okay, do y'all remember what median means? Yeah, but what does it mean in a triangle? Because remember, all those segments that we created kind of had to do with the middle. So a median connects what to what? Because the mid-segment connected two midpoints, right? The median can't do that, or else it would be a mid-segment. So what's it connect? All right, I'm going to tell you. It connects the midpoint to an opposite vertex. So knowing that this is a median means we know that this piece and this piece are equal because they're half of this. Z is a midpoint of this. Okay, that's all we know based on what it told us. It says which additional condition would not be sufficient to prove that triangle XWZ, which is this one over here, is congruent to YWZ, which is this one here. Okay? So we're not saying that they're not, we're saying which piece of information would improve it. Okay? So we have this. What else do we know even though they didn't tell us? I'll give you a hint. It was a common step in all of our proofs pretty much. Maybe not everyone, but a lot of our proofs. Yeah. This line is congruent to itself basically, right? Because they share it. So we have two sides. We're asking what would be not enough information to prove. So this one says that XW was congruent to XW and WY. So XW and WY. Well, if these two are equal, don't we have all three sides? Does side, side, side prove they're congruent? Yeah. So this one does prove it, so it's out. Okay. This one says X is congruent to Y. Okay. So if X is congruent to Y, then that would be angle side side or side side angle, which generally doesn't prove anything, right? Okay, I'm going to come back to this one in a minute because we think we might have it, but there's a catch here. So that's why I say always read them. This one says XY is congruent to WZ. Is knowing that this line XY is congruent to this line tell us anything useful for the two? No. So this one seems out, but we already said that this one doesn't seem to do it. So that's why I said let's come back to that one. And then the last one, I will tell you this is a little bit light. It says that XY was perpendicular to WZ. Okay, that would mean this is a right angle, and then wouldn't we have side angle side? Yeah. So this one would work. So it's out. So let's go back to why we seem to have two answers that don't prove. This one proves nothing, and this one gave us side-side angle, which is supposed to be a no, right? But if I knew that X and Y were equal, what kind of triangle would this be? If it's an isosceles, what would that mean was true?
Another angle is equal. W.
No. What's an isosceles triangle? Two sides are equal. And which two sides would those have to be? XW and X and YW, right? So even though this one seemed to be a no at first glance, it actually would be enough to do a proof that showed they were equal, wouldn't it? So this is one of the prime examples of when I say always read them all, because when we first read that, it sounded like it was going to be the answer, and it wasn't. Because it led us to another piece of information that actually would be enough. Okay.